Alright, so I think I'm recording now. Let's take a look at problems 9 and 10. The directions are the same. Identify the intervals over which the function is increasing, decreasing, or constant, and also to identify whether the function is even, odd, or neither. We see that they've shown us a portion of the graph, and we can assume that this is continuing on now in this pattern forever and forever over here. That gives us two pieces of information about the x and information about the y. X is heading to negative infinity. This arrow means that y is heading to positive infinity. Over here, this means that x is heading to positive infinity and that y is heading to positive infinity. That's what that arrow means to us. Alright, so as we trace out the graph, moving our pencil from left to right, we'll try to use that to determine where the function is increasing, decreasing, or constant. We'll use green for decreasing, yellow for increasing, orange for constant. So I just realized that I hope that people aren't severely colorblind, but I think as the description, as I'm describing it, even if that is the case, I think you'll be fine. So as I enter the graph here, as I move to the right, I have to be moving down, so the function is decreasing, and that continues all the way until I hit the coordinates of this point. Now, it looks like I'm going to have to estimate well, let's just call that x coordinate a -3. And then the function is constant for a very short while until, say, at this point, to where Alright, let's start over. I said that I would use green for decreasing, and I turned around and maybe I'm colorblind myself. Alright, sorry about that. So, alright, so this arrow gives us two pieces of information. Information about x, information about y. This arrow gives us two pieces of information about x and y. You can break it up into components, and since you're going up but also to the left, the x is going to negative infinity, the y is going to positive infinity. Since you're going up and to the right, the x is going to positive infinity, the y is going to positive infinity. If we start on the left and we trace our graph, as we move down, as we move from left to right, we're going down, so the function is decreasing until we hit this point, at which case the function becomes constant, and it remains constant until we hit the y-axis, x equals 0, and then it becomes increasing. And so as I move from left to right, I'm going up. Alright, so for increasing, the x coordinate at this point is 0, and it's any 2 points that are greater than 0. As x increases, y increases. That continues on forever. Where is the function decreasing? As we come into the graph from the left, any 2 points in the green interval. As x increases, y decreases. Alright, as we move from left to right, as we're decreasing, as x increases, y decreases. That happens until we hit this point, which has an x coordinate of -3. We are constant over this interval. I've highlighted in orange, which on the left has an x coordinate of -3, and on the right has an x coordinate of 0. So there's the intervals over which the function is increasing, decreasing, constant. Be careful, don't use y coordinates when you're describing the interval, and recognize that -3, 0 is not a point, that it is an interval of values. Let's determine whether this function is increase or even, odd, or neither. I do not have symmetry with respect to the y-axis. It is not an even function. It is not passing through the origin. If I rotate this graph 180 degrees, the graphs will not be the same. It is not odd. Therefore, it's neither. Alright, so let's take a look at the next one, problem number 10. Alright, we'll try to use the same colors and try and be as consistent as I can. The edge of the graph there is indicated a pattern that we can put arrows there. On the left, to us, this is indicating two pieces of information that since you're moving down and to the left, that x is going to negative infinity, that y is going to negative infinity, and here as the two pieces of information that since it's going up but also slightly to the right, x is going to positive infinity and y is going to positive infinity. If we start from left to right, as we come in and trace out the graph, in this portion of the graph, we increased. As x increased, I was going up as I traced it, so that's increasing, and now all of a sudden I have to change and I go down when I'm in this portion of the graph, and then it changes again and I go up. So I've traced out the whole graph and nowhere was I constant. We're increasing in two intervals, so we're going to need the union symbol. So to describe the intervals over which it's increasing, well, we started here, and so the x there was coming from negative infinity, and any 2 points in this yellow region as x increases, y increased, and that happened to the x coordinate here, which is negative 2. Then we had to go to another interval here to get the same thing, that as x increased, y increased. The x coordinate there is positive 2, and if any 2 points have x coordinates that are greater than positive 2, as x increases, y will increase in this interval all the way to infinity. For decreasing, if we are in the green region, which has endpoints here and here, the x coordinate of this endpoint is negative 2. The x coordinate of this endpoint is positive 2. Remember, when you're writing interval notation, it's always a smaller number, comma, a larger number. If you're in this interval, any 2 points in this interval, as x increases, y is decreasing. Constant, it was never constant. We don't want to leave this blank. We want to indicate that it's never or nowhere, or just simply put a symbol there for the empty set, that there is no interval over which this function is constant. So let's determine whether the function has symmetry or not, even, odd, or neither. Let me erase this work. The right hand side is not a mirror image of the left hand side, so it is not an even function. It is not passing through the origin. It does not have symmetry with respect to the origin. If you rotate it 180 degrees, you do not get the same graph. Alright, so it is neither. Alright, so I hope that helps. I will talk to you later.